Most of us might have used this reverse shell format multiple times. It looks hard to understand, but in reality, it's not. In this video, we will understand how Linux name pipes can be abused by attackers. A name pipe is a type of IPC in Linux, meaning it is a way of sending data between two processes or programs. To create one, we use the make FIFO command. Here we see the pipe created with 0 bytes. This will remain 0 even if we send data inside because they are buffered in memory and not on disk. We can also recognize them as having P at the beginning of the permissions. To use it, we can send data like this. It will hang here because it is waiting for something to read the data out. In another terminal pane, let's try to read it. We can treat it as a regular file, so we can use cat command. Once we read it, the command that writes the data completes. Name pipes exhibits a blocking behavior. That's also the same the other way around. If we try to read something from a pipe that is empty, it will just hang. We need to push data first before the read completes. Now let's have a look at the popular make FIFO reverse shell. To make this less complicated to read, let's break it down into several parts. The first command is just to remove any previous pipes. This is a housekeeping method to make sure any previous broken pipes that may still contain data will not break the current connection being established. The second command is to create the pipe itself, which we already discussed a while ago. The third line is the actual command for establishing connection. Let's do some formatting again to make it more readable. The core part here is to connect back to the attacker listener using netcat command. But doing it using this alone will not help entirely. That's because this is just a raw TCP connection. We need something that will send the commands to the victim machine and send back the output to the attacker. This is where name pipes come into the picture. First, we have a reader that is waiting for a command from the pipe. Once a command arrives, it will send it to a shell to execute inside the victim machine. After the command is executed, the output will be sent back to the attacker via the netcat connection. Then the attacker will type again a command and send it to the named pipe. The cycle repeats, and this provides the attacker an interactive session to the target. Another way attackers can abuse named pipes is when exfiltrating data. Let's create a named pipe inside dev.shm. For demonstration purposes, let's say we have a secret here that needs to be transferred to the attacker machine as silently as possible. What we can do is first compress the content using tar command. Then instead of putting the tarball on disk, we can send it directly to the named pipe. Remember that named pipes are buffered in memory, so it will be harder for antivirus engines to detect this. Then since this will block the call unless there is something that will get the data from the other end, we can put this in the background while waiting for the reader. Then the covert operation doesn't stop there. We can encrypt the compressed data using OpenSSL command so that any traffic monitoring system won't be able to identify the data. At this point, we need to get the compressed data by consuming it from the pipe. Then we will send this to the attacker IP address. Notice also the extra space here before the command. This prevents us from recording the command from history since we passed a credential as a parameter. On the attacker side, there is a netcat listener waiting to redirect the output to disk. Take note that this is already inside the attacker machine, so writing on disk is fine. To confirm that the file was transferred properly, we should see something like this. To decrypt this, we just use OpenSSL command again and pass the secret password. Then finally, since the decrypted data is compressed, we just pipe it to tar command to extract it. Name pipes are one of the common ways programs transfer data to one another. Attackers can abuse them by establishing a connection to the victim machine or exfiltrating data. Those are just a few of them, and there are other ways, such as hiding command parameters inside name pipes to avoid exposing them in the process table. I hope you learned something today. If you find my content valuable, please support me by liking this video and subscribing to my channel. See you on the next one.